Good day! We are here in one of the well-known landmarks in Candelaria, the Lauis Bridge, which was completed in the year 1975 and spans 308 meters. It was formerly named Marcos Bridge since it was built during the Marcos regime, and later renamed Lauis Bridge in 1990 by the virtue of Republic Act No. 6844.
Did you know that there are forces that affect and determine whether the structure of a bridge stays? Come along with us as we investigate the relationship between tension and compression on how bridges work. Beforehand, let us define the forces involved.
Tension is the force that pulls along the axis of a member, creating failures by tearing members away from the gusset plates along the bridge. This force must be considered when constructing a truss bridge structure. On the contrary, compression is the force acting or pushing on both ends of a member. This frequently fails a member, putting the member's integrity in jeopardy. What happens when you compress a spring by pressing down on it? That's true. You squash it and squeeze it, shortening its length. As a result, compression stress is the polar opposite of tension stress. All bridges have compression and tension, and as shown, they are both capable of destroying parts of the bridge as load waves and other forces operate on the structure. The bridge's task is to withstand stresses without buckling or cracking.
The same concepts are applied to the bridge. An example of combined truss and true arc bridge. A truss is a rigid framework made of components that are connected. Assistance load carrying components are called members. Members are placed in interconnected triangles in most trusses. Truss members carry load predominantly in tension and compression due to this design. Trusses are frequently utilized to span great distances because they are solid for the weight. Since the early 19th century, they have been widely utilized in bridges. Nevertheless, truss bridges have become less prevalent in recent years. Trusses can now be seen on the rooftops of buildings, stages and towers, construction cranes, and various other structures and machines.
The truss distributes the weight on a bridge using equilateral triangle. The forces are limited to compression and tension. As a load or vehicle moves across the bridge, the pressures on a member may change from compression to tension, especially to the member near the bridge's center. On the other hand, in a true arch bridge, the forces of compression are pushed outward along the curve of the arch toward the braces, and the tension force in an arch is negligible.
Simply said, tension is the force that pulls materials apart, whereas compression is the force that squeezes materials together.